Hi everyone, welcome back to VRC Smart Hero channel. So we are here with part 5 of chapter 3 matrix. So again we are back with introduction. So today we are going to just look after the introduction of exercise 3.2. So what are the concepts that are required for solving exercise 3.2? That concepts we are going to deal today. Okay. So this is part 5 video. So already part 4 video, that is 1 to 4 video have been posted. So if you want to watch that, the links are provided in the description. You can go and check it out. So watch that so it will be clear for you. Already have made an introduction video for exercise 3.1. We dealt with exercise and example problems also. So go and check it out. The links are provided in the description, and also the link will be popping up above for part 4 video. You can go and watch it out. Okay, so if you are new to our channel, kindly subscribe it and click the bell icon for notification, so that whenever I post a new video it will be coming you in the notification bar. And also like this video if you like it. Come on, let's roll on to the today's video. So today's concept is about addition of matrix. So we are going to study about the addition of matrix. First of all, what is addition of matrix? Addition is nothing but normally we add, suppose a number is given, an integer is given 6 plus 8. Normally what you will do, you will just add these two numbers. Okay, and you will write the resultant as the answer 14. So for example 10 plus 4 14. So like this, some numbers, if integers are given, you will just add it. Okay, for example minus 2 plus 2 0, like this you will just add the numbers, or just integers are given, you just add. But how to add a matrix? Matrix means it will be given like this, right? 2 4 6 8 9 10 8 9 5 4 minus 1 3. So how to add a matrix like this? So that is a greater question that can be asked. So here we are going to make a solution for this question by solving the addition of matrix. Okay, now let us see how to do an matrix addition. Okay, so first for matrix addition there will be two matrix given. Okay, so for example this is my first matrix. I'm going to take 2 by 2 matrix, 8 4 3 2. Okay, this is one of my matrix, and B, this is going to be my another matrix. Maybe 2 1 minus 2 um, 5. This is my B matrix. Now they are asking you to find A plus B. Okay, so A plus B you have to find. Okay, so how to find this one is, listen carefully. Now you have to have certain rules you have to follow here for matrix addition. Okay, first rule is remember, while doing the matrix addition, both the matrix both the matrix A and B should have same order. Same order. So that means the order of the matrix should be same. Okay, so now if you just look after here, this is also 2 by 2 matrix, this is also 2 by 2 matrix. So order of the matrix is same. So whenever you are going to do the matrix addition, in that time the order of the matrix should and must be same. Number 2, what you have to follow is add the corresponding element. That means, see, if you are going to add, see, you have to add A11 plus B11. So this position is A11, this position is B11. You should only add A11 and B11. And for example the resultant is C, I am getting, means, so when you add A11 plus B11 I get C11, like this. So this is how you should add. You should have only corresponding elements. You should not add Anything you cannot add. Only the corresponding elements A11 can be added with B11. Similarly, A22 can be added with B22 in order to get C22. Clear? So, these two things you should keep it in your mind. Then your answer will be very easy. Now, let me remove this question mark. Let me remove this question mark. And now, try to tell the answer by following these two simple steps. By following these two simple steps, you are going to tell me the answer. Come on, tell me. Tell. Yes. So, first you have to add 8 and 2. Okay, so it is going to be 10. Next, you are going to add 4 and 1. Yes, that those places are same. This is A12, this is B12. So, you can add. So, 4 plus 1 is 5. Then, this is A21, this is also A21. So, when you add 3 plus of minus 2, it is going to be 1. And you can add this 2 and you can add this 5. That is A22. So, B22. So, 5 plus 2 you can add. Okay, that is going to be 7. Okay, so this is the answer. When you add A plus B, you will get this as your answer. Clear? Okay. So now, remember this one. Okay. And now, listen here. See. For example, A11, A12, A13, A21, A22, A23. This is my A matrix, for example. And my B matrix is going to be A11, A12, B11, B12, B21, B22, B31, B32. Okay. Now, these are my two matrices given. Can we add these two matrices? First of all, tell me what is the order of this matrix. How should we write the order of the matrix? M by n. M by n, m should be the number of rows and n should be the number of columns. Here two number of rows are there and three number of columns are there. So this is 2 by 3 matrix. Here 3 rows are there, 2 column is there. So this is 3 by 2 matrix. Both are different. When it comes for matrix, 2 by 3 matrix and 3 by 2 matrix are different, entirely different. So now the order of the matrix is not same. So order of the matrix A and B is not same. Therefore, so what you cannot do? You cannot add. So A plus B is not defined. Not defined. That means you cannot add. Since the order of the matrix is not same. Here 2 by 3 matrix, 3 by 2 matrix. It cannot be added. So A plus B is not defined. Clear? You can write A plus B is not defined. Hope you are clear, right? Now, next topic we are going to go on to multiplication of matrix by scalar. So you have two different types in multiplication. One is by scalar, another one is normal multiplication. Multiplication of matrix by scalar is one type and normal multiplication. That means normal multiplication means you will multiply two matrix. Now how I showed addition of two matrix like that. Multiplication of two matrix is normal multiplication of matrix. But here multiplication of matrix by scalar means you will multiply an entire matrix with only one integer. Okay, example I am going to give here. For example, your A matrix, I am just writing your A matrix. Your A matrix is going to be 2, 6, 9, 4, minus 1, 3, 2, 6, 8. Okay, for example, this is your A matrix. Now they are asking you to find, the question is given like this. Okay, question is find 3A, 4A. How will you find? That means you know A, So you have to find 3a and 4a. Very simple. So 3a means it will be nothing but 3a means it will be nothing but, listen here. 3a is going to be equal to 3 into a. A is nothing but 2, 6, 9. 4 minus 1, 3. 2, 6, 8. Now tell what is 3a. 3a is equal to 3. You have to multiply with each and every element. 3 twos are, 3 six are, 3 nines are, 3 fours are, like that. You have to multiply 3 with each and every element in order to find the 3a matrix. Clear? So, 3 twos are 6. Then 6 threes are 18. Then 9 threes are 27. Then 4 threes are 12. Then minus 3. Then 3 threes are 9. Then again 6. Again 18. Again here 24. So here only one matrix will be involved. So if it is 3 by 3 matrix, surely it will also be 3 by 3 matrix. Right, 3 by 3 matrix. So for 2 by 2 matrix, it can, no, it is not needed that it should be only square matrix. It can be, apart from square matrix, it can be 2 by 3 matrix, or 1 by 3 matrix. It can be any type. Okay, for addition of matrix also it can be any type, but in addition of matrix, both the matrix should have the same order. If the matrix A is 1 by 2 matrix, then matrix B should also be 1 by 2 matrix. Clear? That is what. Now tell me, so 4a is very easy. You can yourself tell what is 4a. Right? What is your a? 2, 6, 9. 4 minus 1, 3. 2, 6, 8. So now multiply 4. So you will get 4a. Right? So your 4a is nothing but 8. Then 6 fours are 24. Then 9 fours are 36. Then 4 fours are 16, then minus 4, then 4 threes are 12, 8, again 24, again 30. So this is going to be also 3 by 3 matrix. Okay, right. So this is how you will do the multiplication of matrix by scalar. Clear? Moving on to negative of matrix. So now, what is negative of matrix? First of all, I'll give you a example of a matrix. Okay, so A is going to be the matrix. 4 minus 5, 6, 0 minus 1 minus 2, 8, 7, 4. Now this is your matrix. Now negative of the matrix is nothing but negative of A. So it is represented with negative of A. This is the negative of matrix. That means it's nothing but you have to change the symbols of each and every element in a matrix. So now negative of A, that is negative of matrix, is going to be, for example, if your matrix is, one second, I'll use a bright color so that it will be very much visible for you all. So your matrix A will be, listen, here you have to find the negative of the matrix. So you know A matrix, so you have to change the symbol for each and every element in your negative of A matrix. So it will, 4 will become minus 4, minus 5 will become 5, 6 will become minus 6, 0 is 0, then minus 1 will become plus 1, minus 2 plus 2, minus 8, minus 7, minus 4. So, and it remains 3 by 3 matrix. No change in the order of the matrix, but the elements present in the matrix will undergo the change of symbol. That means you're multiplying the negative symbol to it. So when you multiply the negative symbol to it, automatically the symbol will change. That's it. So negative of matrix is nothing but in the negative of matrix, the symbol will change for each and every element of a matrix. Clear? Okay. So difference, next we are moving to difference of matrix. So Difference of matrix. What you should remember here, in difference of matrix also, it is same like addition of matrix. The same thing you have to follow here. So first one is the order of matrix should be same. Order of matrix should be same for both A and B. So for both A and B matrix, order of the matrix should be same. Next, second one what we saw is corresponding terms. Corresponding elements should be subtracted. Okay, so corresponding element should be subtracted. Um, okay, subtracted. So now listen here. So corresponding element should be subtracted. I'm going to consider here the A matrix and a B matrix. So A matrix is going to be something like 4, 8, 6, 2, and my B matrix is going to be 0, 5, 4, 1. So you have to subtract A minus B, and be very careful when you just add. There is no problem because addition from A to B, if they are given A plus B or B plus A, the answer is going to be same, because first you have to consider the A element and next you have to consider the B element. But whenever you consider the A element or B element, when you add, everything is going to be same. But when you are going to subtract, be careful whether they have given A minus B or B minus A. If they have given B minus A, from B you have to subtract A. That is, from the elements of B you have to subtract the elements of A. A minus B means from A you have to subtract B. That you have to keep it in your mind, because the answer will not be same in subtraction, that is in differentiation. Okay, differences of matrix. In addition of matrix is not going to be the problem. Okay, so be very clear with that. Okay, now A minus B, so from A element you have to subtract the B element. So no problem. So 4. 4 minus 0 is 4. Then 8 minus 5. 8 minus 5 is going to be 3. 6 minus 4, 2. 2 minus 1, 1. So this is going to be your A minus B matrix. So if it is B minus A, then you have to subtract from B. Remember that. It's very carefully you have to look after this, because most of them will make mistake here. Clear? So now we are moving on to the next. So this is nothing but properties of matrix addition. So now we studied about matrix addition. What are the properties you can use for matrix addition? That is what we are going to study now. So derivations are not important when it comes for properties. When you are studying the properties in board examinations, they will not, even in JEs or in competitive exams, they will not ask the derivations. But knowing the derivations is good only. You can just look after your book. But properties of matrix addition is very important. Okay, apart from derivation, properties is very important. Now coming on to the properties of matrix addition, the first property that we are going to look after is going to be the commutative law. Commutative commutative law. Okay, right. What is all about this commutative law? So commutative law is nothing but, I already told, you have to know, you don't have to bother much about when it comes about the addition, because when you add A plus B matrix, okay, that is going to be the same answer when you add B plus A matrix. So both are going to be same. A plus B matrix and B plus A matrix are going to be same, but it's not in the case of there is the subtraction. So I told there to be careful. So look here, this is a commutative law, that is A plus B will be equal to B plus A. We already know, right? I already told this. Now next, second one is going to be associative law. Associative law. So what is all about associative law? Suppose you have three matrix A, B and C matrix. Then you can say that say all are having the same order. Here also same order. In all the conditions, same order. Order of the matrix should be same. A matrix, B matrix should have the same order. In associative law, you are considering three matrix. All the three matrix should have the same order. Okay. If your A plus B into C matrix will be equal to A plus A into B plus C matrix. A into B plus C matrix. Clear? So A plus B into C matrix will be equal to A into B plus C matrix. All are matrix. Respectively, A, B and C, all the three are matrix. Should have the same order. Okay. This is associative law. Then existence of additive identity. I'll write it. Third one is existence of additive identity. Okay. So existence of additive identity. What does it mean? So it's nothing but see additive identity. So when you are going to have what is the meaning of additive identity? That means when you add something, okay, when you add two numbers or when you add two matrix, you should get the same value. Suppose you add the A matrix to any other matrix, you should get the same A matrix. So, which is going to be the additive identity means, see, when you add A plus, already I told the zero matrix or null matrix is represented with the letter O, right? So, I already told us the zero matrix is represented with the letter O. So, when you add A plus O or that O plus A, that is going to give you A. That is going to give you A. So you are going to get the same value A. That means your A matrix is again restored. So your additive identity is going to be nothing but your null matrix. Okay. So your null matrix is going to be is the additive identity. Okay. Next, fourth one. Fourth one is going to be final one. Existence of additive inverse. Existence of additive inverse. What is the meaning of additive inverse? Opposite. Inverse in the sense opposite. So additive inverse means, for example, if A is the matrix, what will be the additive inverse of A? The additive inverse is going to be the negative of A. Additive um, additive inverse is nothing but minus A. That means the negative of A. If A is the matrix, then the additive inverse is what? It is negative of A. Clear? So that is about properties of matrix addition. Okay. Now moving on to properties of scalar multiplication. So already we studied about scalar multiplication. Now we are looking after the properties of scalar multiplication. So when you talk about the properties of scalar multiplication, look carefully. See, your first property is going to be when you have just take the values. So your A and B are going to be our matrix. The letter A and B I'm going to use here are going to be matrix, and the letter K and L I am going to use are scalar. That means they are going to be numbers. Clear? So when you have K into A plus B, you will have answer as KA plus KB. KA plus KB. Number 2 is when you have K plus L into A matrix, then the answer will be Ka plus La. Okay. So these two properties are very very important, and the derivations for these properties are given, and that will not be asked in any of the examinations. So but these are important, that you have to use this in your while solving the problems. Clear? Properties of scalar multiplication. Okay. Next, starting with multiplication of matrix. So multiplication of matrix is very simple. You have to just understand. Okay, whatever I'm telling, if you understand it carefully, then multiplication of matrix is very very simple. First, in multiplication of matrix, let us look after the 2 by 2 multiplication. Okay, then we will move for 3 by 3 multiplication. Okay. So look after here, when you multiply two matrix, okay, when you multiply two matrix, the order of the matrix, if suppose the order of the matrix A is m into n, the order of matrix B is equal to n into p. Then the order of the matrix, resultant matrix C is going to be what? The order of the resultant matrix C is going to be m into p. Remember this. This is very important. Okay. Now, I'm going to give you two matrices and you are going to multiply for me. I'll just first show an example of 2 by 2 matrix multiplication. Okay, there multiplication, it's not necessary that you should always have the same order. Okay, it's not necessary like that. So I'll show you, for example, 2, 5, 8, 10. It is going to be multiplied with 4, 40. Now, listen, tell me the order of the first matrix. What is the order of the first matrix? So, it is having 2 rows and 2 columns. So, it is 2 by 2 matrix. 2 rows, 1 column. So, this is 2 by 1 matrix. So, what will be your answer? Your answer will be in what order? Your answer will be in 2, 1. 2 by 1 matrix. Okay, your answer will be in your C matrix will be in 2 by 1 matrix. Okay. Now, how to multiply? I will tell you. Listen here. How to multiply? Now, look here. First, I told 2 by 1 matrix. Now, if you are going to take this first matrix, always your first matrix, you should consider the rows. You should consider the rows. Always in first matrix, listen carefully, then only you can do very easily the matrix multiplication. Very very easy is matrix multiplication, but most of them will face problem here. If you listen carefully, then it will be easy only. Okay, first matrix you should take only the row. Second matrix you should consider only the column. So first matrix, first row, first element only you should multiply. Suppose 2 into 4, you have to multiply. 2 4s are 8. So 8. Okay. If the color is not visible, I'll make it with another color so that will be visible. So 8. Okay. So next 5. 5 into 40 you have to do. Okay. It is going to be 200. Plus 200 you have to put. Listen carefully. First you have to take first row, first column. First row of the first A matrix and first column of B matrix. First row, if two elements are there, first row if two elements are there, A11, A12, here B11, B21. Two elements are there, then A11 should be multiplied with B11, A12 should be multiplied with B21. Okay, like this you have to multiply. After multiplying, the first row element should be written here, it should be added. That is A11 into B11 you have done. That you have to first write. Then A12 into B21 you have done. That you have to write the next, and you have to add this both. And here again 8 into 4, again A21 you have to multiply with B11, A22 again B21, you have to multiply that. Now 8 into 4, okay, that you have to multiply 32 plus. Now 10 into 40 you have to multiply, it's going to be 400. Okay, 400. Now you have to just add all these things. When you add, what you will get? You will get 208 as your first result and 432 as your second result. So 2 into 1 matrix. That's all. This is the answer. Clear? So very simple. Now doing it with few more examples so that it will be easy for you. While doing exercise, you will feel much better. Okay. But before that, I should give you a few examples so that you will be better while going for exercise and example problems. Okay. Listen here, now another example that we are going to have here. I'm going to write the question now. Okay, so 2, 5, 8, 10 into 5, 4, 5, 4, 2, 1. Okay, so now how to multiply? Now before that, tell me what is the order of the matrix? 2 by 2 matrix. This is also 2 by 2 matrix. So your answer will also be in 2 by 2 matrix only. Your answer will also be in 2 by 2 matrix. Now how to find the answer? So first matrix you have to split it into rows. Second matrix you have to split it into columns. So first row, second row, first column, second column. So multiply first row, first element into first column, first element. Then second row, first row, second element, first column, second element. Like that you have to multiply. Now after completing this, first multiply this, after completing this I'll tell. Okay, so first you have to multiply this element. 2 5s are 10. Then 5 2s are 10 plus 10. That's all. Okay, and here now 10 10 you got. Now again, now what you have to do is, now you have to just consider this 2 and this 5 and multiply with 4 and 1. Okay, 2 into 4, 5 into 1 you have to multiply. Okay, so and you have to write it at the top. So 2 4s are 8 plus 5 ones are 5. Now bottom same way, 8 into 5 you have to do, 10 into 2 you have to do. So 8 into 5 is going to be 40 plus 10 into 2 is 20. Similarly 8 into 4, 32 plus 10 into 1 is 10. So now this is going to be 2 by 2 matrix. So 10 plus 10 is 20. Then 40 plus 20 is going to be 60. 8 plus 5 is 13. And 32 plus 10 is going to be 42. So this is your answer of 2 by 2 matrix. This is how you solve 2 by 2 matrix. Clear? So 3 by 3 matrix also same. You will split 3 rows and 3 columns and you will do. That's all. Clear? Now one more important thing. When you talk about the matrix multiplication, here you have the commutative law. Commutative law, normally when you talk about the multiplication, 2 into 3 will be equal to 3 into 2. Both are equal. Both are equal. Both you will get the answer to be 6. But when you talk about the matrix multiplication, the commutative law is not applicable. It's not applicable. That means, what is that meaning? That is B will not be equal to BA. That means A into B will not be equal to B into A. Okay, A into B will not be equal to B into A. Because you just look here, if this is A, this is B matrix. A matrix we are considering only the row. B matrix we are considering only the column, so it will differ. So commutative law is not applicable for matrix multiplication. That means AB is not equal to BA. Clear? So, and next one is going to be, if you have to get the zero matrix, zero matrix in during the multiplication, it can be achieved only by multiplying it with non-matrix number. Okay. So zero matrix is the product of two non-zero matrix. Two non-zero matrix. So for this, so when I make the examples video, at that time we can able to look after this zero matrix. Okay, so that it will be easy for us. Okay, so now moving on to the properties of matrix multiplication. Okay, properties of matrix multiplication. Properties of matrix multiplication. So what is here, we are going to just look after the property of matrix multiplication is, first one is going to be associative law. Associative law. What is in associative law? That is, see, for any three matrix ABC, we are going to consider three matrix ABC. So your A into B first you are doing, and when you are multiplying it with C, or first you are multiplying B and C and multiplying it with A, both are equal only. Okay, equality will be defined on both the sides. Clear? Then distributive law. Then distributive law. Distributive law. So what is all about the distributive law? Distributive law, when you just look after, that is A into B plus C will be equal to, when you multiply, what will happen? A into B plus A into C. Okay, so that is, you are just multiplying, you know distributive law, right? When you have an element outside, you can multiply it with both the numbers. That is, A can be multiplied with B as well as with C. Okay, so A into B plus A into C. Okay, so when you are having like this, or the second condition is, when you are having A plus B into C, that time C can be multiplied with both the values. So you can get AC plus BC. Clear? So this one. And the third one is going to be existence of multiplicative inverse. Existence of multiplicative. So existence of multiplicative identity. So here, in existence of multiplicative identity, you just see, whenever you consider the matrix A, okay, matrix A, it is going to have the identity matrix with it. That means IA will be equal to AI. Whenever you multiply the identity matrix in any order, it's going to be same. Okay, because identity matrix is same. Okay, so that will be giving you the same matrix A. So this is the, so identity matrix is going to be the multiplicative identity. What is a multiplicative identity? Is going to be the identity matrix. Identity matrix is going to be the multiplicative identity. Okay, so one second. Okay, clear, right? So multiplicative identity is this. Hope you are clear with this concept. So that's all the concepts we have looked after for exercise 3.2. These are the concepts that are required for exercise 3.2. So I wanted you all to practice the matrix multiplication. Okay, take varieties of sums and just practice the matrix multiplication, because most of them are going wrong in matrix multiplication. And if you do 3 to 4 times the matrix multiplication, if you solve few problems, surely you will get to know about much idea about matrix multiplication. Okay, so if you want, in this video also, now I'll be giving you few questions. Okay, so to solve, so here I'll be giving you with few questions based on the matrix multiplication. Today, after watching this session, try these questions at home. Okay, make a new note for maths and try these questions at home. Okay, in next session, surely I'll be solving these questions, and you can check the answers from the next session. So kindly do these problems, because it will help you a lot in improving your matrix multiplication. When you do a lot of problems, surely will improve your matrix multiplication. So do this problem, and just you can also post your answers in comments. I'll just check the comments. Who are posting the answers will get comment from me. So just post your answers in the comments also. I'll check that. And if not, the next video I will just write the answers. I'll make sure I'll put the answers in the next video. So until then you have to wait. Okay. So now I'll be giving you the questions. Kindly note it down. Your first question is going to be, see, this is 2, 3, 4, 3, 4, 5, 4, 5, 6. You have to multiply it with 1 minus 3, 5, 0, 2, 4, 3, 0, 5. Okay. So consider this as your A matrix and consider this as your B matrix. You have to do A into B matrix. What you have to do? You have to do A into B matrix. That means you have to take, I'll give you clues also here. I'll just tell you how to do, but you are going to do it. Okay. So first you have to take this A into B matrix. So A matrix, you should take only the rows you have to take. You have to consider only the, uh, you have to just consider only the rows. Okay. And here you have to just consider only the columns. So first row, first column, first row, second column, first row, third column. Do it and you have to add it. Then second row, first column. So this is also 3 by 3 matrix. This is also 3 by 3 matrix. So your resultant C will also be 3 by 3 matrix. So try doing this question. Next video I'll surely post, I'll make the answers for these questions. Okay. So first you have to take the rows, then multiply it with the column, so that you will get again 3 by 3 matrix you will get. Okay, kindly do this. And second question, only 2 questions homework. So homework questions, these are only 2 questions I'm giving homework. Kindly do this. I have also given how to do this problem. I have given the basic introduction for that. So with that introduction, you can easily do the problem. Okay, so you can do it. Now another question is very easy question I'm going to give you. 1 minus 1, 2, 3. Going to multiply it with 4, 0, 1, 5. So what you have to do here, this is very simple problem again. This is 2 by 2 matrix. This is also 2 by 2 matrix. So split it first. If this is A matrix and this is B matrix, here you have to find, see, I'm giving you one difference here. Here you have to find B into A matrix. So your C matrix will surely be 2 by 2 matrix only. So here you have to find B into A matrix. What is the difference you have seen here? Already I told A into B matrix is not equal to B into A matrix. So be clear. You have to take this as your row and this as your column. Okay. This you have to consider it as row. So first row, first column, first row, second column. You have to do like that. Okay. You will get 2 by 2 matrix. First row, first column, first row, second column, second row, first column, second row, second column. You have to do, add it, and finally you will get 2 by 2 matrix as your answer. Only 2 questions. Do it as a homework and meet you in the next video with this question. I'll just solve and show you. Okay. Okay. So that's all for today's video. Thank you so much for watching this video. Kindly do the homework. Okay, so it will help you a lot. In next video, we will be upcoming with these questions. First, I will solve, and let us move to the example problems that are given in your NCRT textbook. Clear? So thank you so much. Meet you in the next video. So kindly subscribe to our channel and like the video if you like it. So thank you so much and meet you in the next video. Until then, bye.